Now you just learned that a compound inequality is one in which you have two inequalities joined by the word and or the word or. Now what we're going to do next is consider some simple compound inequalities to establish a procedure that can be used to solve more complicated ones. And our first example is this: x greater than 1 and x less than 5. Now remember that the word and means the same thing as intersection. So what we'll do next is to convert each of the inequalities into interval notation and replace the word and with the intersection symbol. Now the inequality x greater than 1 can be rewritten then as the interval 1 comma infinity, and you'll notice that there's a parenthesis around the 1 because it's not included. We've changed the and to the intersection symbol, and x less than 5 translates into the interval negative infinity to 5, and again notice there's a parenthesis around the 5 because it's not included. Now at this point, this problem should look very, very similar to ones that we've considered earlier in this module. Now what we can do as an aid is to graph each of the intervals in relationship to a number line and look to see where those two intervals overlap. So we'll do that next. Now you can see that the first interval, 1 to infinity, is graphed in green above the number line, and the second is graphed in blue below the number line. And based upon work that we've done earlier in this module, I think you'll agree that where those two graphs would overlap would be between 1 and 5. And that interval then is graphed in red on the number line itself. Now what we'll do then to end up will be to express the solution either in interval notation or in set builder notation involving the variable x. So the solution expressed in interval notation would be the interval from 1 to 5, and in set builder notation would be the set of all x such that 1 is less than x, which is less than 5. Now our next example will involve the word or, which involves union. Now our next example involves the exact same inequalities as the first one, except this time the connector is the word or. And the first several steps here will be the same as the first steps in the previous example. We're going to translate each of the inequalities into the appropriate interval. We're going to replace the word or with the union symbol. We're going to graph each of the intervals with respect to the number line, then determine from that what the union of those intervals will be. So again, x greater than 1 translates into the interval 1 to infinity. We've replaced the word or with the union symbol, and x less than 5 translates into negative infinity to 5. And as before, each is graphed there, one above and one below the number line. And I trust you'll remember from earlier work in this module that the graph that would include all the points on both of those would have to be the entire number line, which you can see is graphed here in red. So that would tell us then that the solution is all real numbers, and it will be most convenient, I think, in this case to express that using interval notation. So we'll simply write then the solution is negative infinity to infinity.